Welcome back. These are the 5.6 notes, rational functions. This is page 2. Page 2. So this one will go a lot quicker than page 1. On the left-hand side, for any rational function, f of x equals p of x divided by q of x, right here. P and x and q of x are polynomial functions with no common factors. That means we cannot cancel something, numerator and denominator. So any a that is a 0 of the denominator gives us a vertical asymptote at x equal a. So let's take a look at example 2. We're going to put this up here. It says graph a function that has asymptotes at x equals 0 and x equals 4. And I will tell you that a lot of times students find this kind of unsettling because other than the fact that I have an asymptote here and an asymptote here, I don't even really know what the function looks like, and that is okay. All that matters is I have those two asymptotes. So whatever I want to draw in here is fine. Yeah. As long as I don't cross those asymptotes. The one thing that I can say for sure is that x minus 4 and x minus 0, or just x, are factors in the denominator. Guess I could have planned that a little better. And cannot be canceled. Now, that's a little different than what we're going to talk about below here. We have two types of discontinuities. There's the kinds that we have looked at, which is non-removable, and those are our vertical asymptotes. We also have a removable, which we're going to look at here in a minute. And that's going to give us a hole. Okay? So there's going to be a hole in the graph. The thing is, you have to know where those holes are, because if you graph on a graphing calculator, even in Desmos, they're not going to show you the holes in the graph unless you hover over that point specifically. Okay. So let's take a look at how this plays out in f of x. I'm going to factor the numerator. I get x times x minus 4. And I'm going to factor the denominator, x times x squared minus 1, and I can factor that further. Our removable is this right here. Gotta be smarter than that. So I have a hole at x equals 0. I don't actually know what y is when x equals 0, but this x over x works like a big giant 1. So that means what I have left, x minus 4 over x minus 1 times x plus 1, that is an equivalent equation to f of x everywhere except for x equals 0. So I'm going to write that here. Equivalent to f of x except at x equals 0, which was our whole. Cancel from numerator and denominator. So I'm going to go ahead and use what I can here. I know I can take these factors in the denominator and find my asymptotes. So I'm going to sketch in my asymptotes here. X equals -1, x equals +1. And then I'm going to take a look at what other information I have. So I'm going to take a look at the numerator here. Specifically this part, because if my numerator equals 0, the whole ratio is going to equal 0. 0 divided by anything is 0. So that means when x is 4, y's got to be 0. So the numerator tells us our y-intercepts. So I got to figure out how this looks, and I definitely did not plan space well here. Let's see if I can add a page. Cool. I'm going to stick my notes, rewrite these notes. Now notice here when I say x cannot equal 1, that means I cannot plug in the value 1 for x, which is why that vertical dotted line is drawn right there. Okay, so we got those. So now I got to figure out what the graph looks like. So here's my equivalent graph, f of x. Let's call it g. And I can use this to plug values in and figure out what my graph looks like. So that's all I'm going to do. I know in my f of x I have a hole at x equals 0. But if I plug it in here, I get -4 over -1, I get +4. I know that that's a hole in my graph, so I'm going to draw it like that with the hole. I'm going to try +1/2. And then I'm going to do something kind of sneaky here. 1/2 minus 4 is -3.5. In my denominator, 1/2 minus 1 is negative 1/2. 1/2 plus 1 is positive 3/2. I have a negative over a negative. I know this answer is going to end up being positive. Now, here's what else I know looking at my graph. I know that this cannot go down because then it would cross my asymptote. We haven't really talked about horizontal asymptotes, so let me back this up really quick and fill in this number. I got negative 7/2 divided by negative 3/4. Negative 7/2 times negative 4/3. I'm going to cancel my 2's here. I get positive 14/3, which is roughly 4 2/3. Cool. At positive 1/2, 4 2/3-ish right there. So I know this side is going up this way. I can do the same thing with negative 1/2. I get negative 1/2 minus 4, negative 1/2 minus 1, times negative 1/2 plus 1, negative 4.5, so negative 9/2, divided by negative 1/2 minus 1 is negative 3/2. Negative 1/2 plus 1 is positive 1/2. Negative 9/2 divided by negative 3/4. And I'm going to drop the negatives now. I know my answer is going to end up being positive 3, 2, we get 6. Negative 1/2. Now, do I know that that 0,4 is the lowest point? I really don't. But you don't need to get super precise with these. You just have to establish that you understand the key parts. Okay. So, kind of got to figure out what it looks like to the left and to the right. Notice I have that 0 at 4. So I'm going to plug in, 2 and 5. Positive parts over here. 2. Which gives me a 2 minus 4 over 2 minus 1 times 2 plus 1. Negative 2 over 1 times 3. Negative 2/3. Let me move my 1/2 a little closer. So that makes a little more sense. And then I said 5? Got 5 minus 4, 5 minus 1, 5 plus 1. 5 minus 4 is 1. I got 4 times 6. We get 1 over 24. So I know at 5, it's really, really close to that x. And at 2, it is negative 2/3. Now, here's the thing. I know it's going to approach this vertical asymptote. It's not going to cross. And then I know I've got to hit these 2 points over here. Now let's see what it looks like to the left of that asymptote at negative 1. Would it be fabulous if we could just plug this into a graphing calculator at Desmos? Yes, it would, but again, neither of those is going to explain where the hole is. And if you don't understand what's going on with the equation, you're going to see those asymptotes in a graphing calculator like they're part of the graph. So I got a -6 up here. -2 minus 1 is -3. -2 plus 1 is -1. -6 over +3, -2. So at -2, we got a -2. For fun, let's just use -5. See if we can balance the other side. So I got -5 minus 4 over -5 minus 1 times -5 plus 1. And we get -9 over, what is that, -6 times -4. -9 over a +24. Divide them both by 3, and I get -3/8. So at -5, I am at -3/8. So approaching my vertical asymptote here. I don't have another 0 or another x-intercept, so I know this is never going to cross that x-axis. Okay, there's my sketch.